Welcome to the Georgia Highlands College Math 97 and Math 99 instructional videos. In this video segment, we'll be answering the question, how do I apply factoring to solve an area application problem? Now, the particular problem that we're going to be working with will be a quadratic. So, the first step in this process is to let x represent one of the quantities, usually the first unknown that you encounter. The second step would be to represent any other unknown quantities in terms of x. So you don't want to add another variable in there. You want to see if you can talk about the other unknown quantities using the same variable x. Then you write an equation from that model, and in this particular problem we'll be writing a quadratic model, and you finally solve and check your solution. So let's take a look at this word problem example. We'll start off by reading our word problem. A vacant rectangular lot is being turned into a garden measuring 15 meters by 12 meters. A path of uniform width is to surround the garden on all sides. If the area of the lot is 378 square meters, find the width of the path surrounding the garden. So you can see I drew a little garden here with a path surrounding it of uniform width. Well, use your imagination on the uniform width, but it's surrounding the garden on all sides. And the first step in our process is to identify what we would like the variable x to stand for. So since what we're trying to find is the width of the path surrounding the garden, we don't know that value, so we'll call the width of the path x. And I'm just showing that width is the same on all sides. So x is going to stand for the width of the path. Now we have other information that we're given in the problem. We see that the garden measures 15 meters by 12 meters. So this is just the garden portion, not the path included. So we have 15 meters by 12 meters. However, if we're talking about the area of the entire lot, that's talking about the garden as well as the path. So we need to figure out how we can call the length and the width of the entire lot here, including the pathway, so that we can use our area formula, because we're given the information that the lot is 378 square meters, and that is an area that we're talking about. So we know from previous lessons that area is equal to length times width. So I just wrote that formula next to my little drawing there, just to remind myself of how to calculate the area of a rectangle. So let's proceed with trying to talk about the length and the width of this lot in terms of x. Well, let's start with the length of 15. So we know that 15 goes the length of the garden. However, we have the pathway on either side to account for. So, putting that all together, we have that the length of the garden is equal to 15 that we were given in the problem, but then we need to add the length of the path. So, plus 2x, since we have an x on either side of the length of the garden. Now let's look at the width of the garden. So we're told that the width of the actual garden is 12. However, we also have the path on the top and the path on the bottom to account for. So we could say that the width of the entire lot is 12 plus 2x. So that step, the second step, asks us to represent any other unknown quantities in terms of x, which is exactly what we did. We didn't bring in any new variables. We simply used what we had to express how we could call the length and the width of the entire lot. Now we're ready to actually plug these things into our area formula. Once again, we are told in the problem above that the total area is 378 square meters. So we simply need to plug in each of our pieces into our area formula. So our length will go there. We will also plug our width in to the formula. And finally, we will plug our area in as well. So we'll start with the formula area equals length times width. Our area is 378. We have called our length 15 plus 2x, accounting for that path on either side of the length of the garden. And our width is 12 plus 2x. So you can see in writing this equation, we have created a quadratic, because as soon as we multiply 2x by 2x, it's going to become 4x squared. And since we have a squared x in there, 2 is our degree, which makes this a quadratic equation. So to solve this quadratic equation, we were shown in a last video that when you have something that looks factored on one side, but it's not equaling 0, you actually have to multiply that factored looking side out and then bring that 378 over by subtracting it to create your quadratic equation being equal to 0. So we'll start by distributing each term in the first binomial with each term in the second binomial. And that gives us that 378 is equal to, well, 15 times 12 is 180, and 15 times 2x is positive 30x. Coming back and distributing the 2x, 2x times 12 is positive 24x, and 2x times 2x is positive 4x squared. So in this next step, we'll go ahead and combine our like terms of 30x and 24x, and I'll also go ahead and subtract 378 from both sides of the equation. So we end up with 0 equaling negative 198 plus 54x plus 4x squared. We're still not in standard form, so let's do some rearranging. And we just want to put our exponents in descending order to be in standard form. All right, so now we're ready to factor the right-hand side of the equation. And we do have a GCF that we can take out that'll make it a little easier on us. And that GCF is 2. When we divide each term by 2, we're left with 2x squared plus 27x minus 99. And now if we look inside the parentheses, we see that we don't have an a of 1, so we need to employ the grouping, or also known as the AC method, or you could use trial and error. I'm going to use the AC method. So the first step in that is to find a times c, which in this case is 2 times negative 99, which gives negative 198. And we're looking for the factors of negative 198 that add to make 27. And after some playing around with my calculator, I figure out that those factors are 33 and -6. All right, so the next step in this factoring process is to factor by grouping. So I'm just going to set up a big bracket here so I can have room to do my factoring. So I have to set up my grouping by rewriting that polynomial, 2x squared. I don't want to write plus 27x. I write plus 33x minus 6x minus 99. And I can come back and group my terms together. And now I'm ready to pull a GCF out of each of those. So the GCF of the first two terms is x. And when I divide that out, I'm left with 2x plus 33. And the GCF of my second two terms is -3. And when I divide that out, I get 2x plus 33. My new GCF is a greatest common binomial factor of 2x plus 33. And when I divide that out of both terms, I'm left over with x minus 3. So the fully factored form here is 2 times 2x plus 3 times x minus 3. Now that we've got this polynomial factored, we are ready to apply the zero product principle. So I'll come up over here and set each of my factors equal to 0. Well, 2 does not equal 0, so we don't have to worry about that one. But 2x plus 3 could equal 0, and x minus 3 can equal 0. So for this first one, I first subtract 3 from both sides and get 2x is equal to -3. Divide by 2, and I get x is equal to -3 halves. Moving to the next one, let me just put a little line in between so they don't run together. I have x minus 3, so to solve this equation, I just add 3 to both sides, and I get x is 3. Now, I have two potential solutions here. Let me just call your attention to them. I have the potential of x equaling -3 halves and x equaling +3. Well, to decide which one of these answers our question, we need to go back and remember what the x was standing for. So that's why we always identify our variables. X is standing for the width of the path. So when you're talking about a length, you can't measure a negative length, not in this dimension. So we can consider x as -3 halves, although it's a valid solution to the actual quadratic equation, it's not a valid solution to our particular problem. So we don't even need to consider x being -3 halves as a valid solution, which leaves us with x equals 3. So, since this is a word problem, we should answer this with a complete sentence. And that is, the width of the path is 3 meters. So there's our solution sentence. I hope that this has helped you understand how to apply factoring and using the zero product principle to a word problem situation having to do with area. Once again, you always want to let x represent your unknown quantity. then you want to write any other unknown quantities in terms of x. Remember, don't bring in more variables. Finally, write your equation model, solve it, and check it. Now, we didn't check this one because I ran out of room, but it's valid, it works, it checks out. You can check it on your own at home. So if you have any other questions about these types of word problems, please make sure to contact your Highlands instructor. Thank you.